In this problem, I'll talk about the Coulomb's force. The Coulomb force between the two charges. We have two charges on a ball, plus 10 microcoulomb, and again another plus 10 microcoulomb. Those two are positive charges and are separated in a space, into free space, into air, by 1 kilometer. So the distance between the two charges is 1 kilometer, which is a big distance. Now let's find out what is the magnitude of the force between them. And as both charges are positive charges, this is a positive charge and this is a positive charge, they will repel each other. So the force onto this one will be this way, and the force onto this will be in the opposite direction, and they will repel each other. Now let's find out what is the magnitude of the force between them. By Coulomb's law, the force between two charges is given by this equation here. Q1 is the magnitude of the first charge, and Q2 is the magnitude of the second charge. And K is a constant quantity. And this K, of course, depends upon the medium in between, for air, or whether it is into the water, whether it is into the wood, whether it is in a plastic. So this one depends upon the space between them. As this is in air, so we have to take the value of K into the air. And this is a constant quantity. For free space, this value is given by this value, 9 times 10 to the 9 value. So you have to remember this one, because most of the time you will be using. So keep this one, the value of K in mind. And this value is for the free space for the air. Okay, 9 times 10 to the 9. And Q1 is 10 Coulomb here. This is Coulomb. And Q2 is Coulomb here again. So if we solve this one, the force we get is this force here, 9 times 10 to the 5 Newton. And remember, the charges are in Coulomb. So this force is a huge force. So if you want to understand the immensity of this force, what you need to understand is this force is equivalent to the weight of the 92 cars. So if you have cars, and if you keep piling another cars on the top of each other, then at the bottom, if you have 92 cars, then the force at the bottom will be equal to this much force. That much force acts between the two charges here, just the two charges. And remember that this charge is in Coulomb here. So what does that mean? The Coulomb is a huge charge. 1 Coulomb is a huge charge. So in general, the charges are expressed in either microcoulomb or in nanocoulomb or in picocoulomb. Those are the most preferred unit of the charges. But 1 Coulomb is a huge charge. So it's okay. So whenever we rub the charge on the two objects, whenever we rub one object against another, the charges usually happens in the form of nanocoulomb, or at most the microcoulomb. If there is a 10 Coulomb charge, that means there will be huge repulsive force. Okay, so if you need to understand how I get the 92 cars, so let's say the mass of each car is 1000 kilogram. Okay, G value is 9.8, and then here I'm solving for the N is the number of cars. If you solve it, you'll get the 92. So this force is equivalent to the 92 cars, and the mass of each car is 1000 kilogram. So this is it from the Coulomb's force between the two charges. The idea for talking about this problem is to convey you that the 1 Coulomb charge is a huge charge, and this charge usually happens when the lightning clouds, when the two clouds slides against each other, then there may happen this huge amount of the charges. So this is it. Again, if you have any questions, write down your questions in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.